Hello everyone. Today I want to talk about these worksheets, the enthalpy change, the worksheets that I gave you before. I hope you have tried the question because I'm going to go through all the questions with you. Okay. Okay. So let's take a look on the first one. Hello. What's the enthalpy change of formation of iodine trichloride (ICl3)? So I will start by copying this one first. Okay. So now from here to here, I use this one, okay? So it's I2 solid, right? And this is positive. From gas to solid, so it should be negative, agree? Because from solid to gas is positive, am I right? Then you just add this one, then it will go to this one, right? So this is basically the formation of this one, two molecules of ICl3. So this is two molecules of ICl3, right? Because there are two. If you remember, the definition of formation is the enthalpy change when one mole of ICl3 is formed from its element, okay? So this one is given. Then I basically have the enthalpy, the cycle, right? Energy cycle. And I can put them together. Okay, I can put them together. This one will be equals to this one plus this one, right? So it will be equal to negative 214, okay? Equals to negative 38 plus this one. So will be negative 88. Okay, the answer is B. Okay, then we go to another one. 50 cm cube of 2.5 hydrochloric acid react with sodium hydroxide, and it will form this one together with this one, right? Okay, the temperature rose by 17. Resulting solution have a specific heat capacity. What is the possible value for molar enthalpy change of neutralization? If you still remember, it's basically the energy released when 1 mole of water formed, okay? And it's always negative because neutralization is exothermic. So how are we going to tackle this question? We will have 15 mil here, 2.5, okay? 15 mil here, 2.5, okay? So the number of mole of acid, for example, acid and alkaline, their amount is the same. So it's the same. If I look at the number of mole of hydrochloric acid, it will be C times V, right? So it will be the 2.5 times 50 times 10 to the power negative 3. Now, since this is 1 to 1, right? So the number of mole of water will be the same. It will also be 2.5 times 50 times 10 to the power of negative 3, okay? So that is the number of mole of water formed. Remember this number first, okay? Then we use delta E equals to mc delta T to work out the total amount of energy released from the neutralization reaction. So now M is the mass of the resultant solution. You have 50, right? So it will be 100 cm cube, and we always assume the density of water is 1. So 100 cm cube equals to 100 gram times specific heat capacity times the temperature rise, right? So right now, if this amount of mole is produced, then this amount of energy will be released as well. Then what will be the amount of energy released when 1 mole of water is produced? Then that will be the negative, right? Because it is neutralization exothermic equals to delta E over the mole of water, right? So that will be negative 100 times 4.2 times 17 over 2.5 times 50 times 10 to the power negative 3. Now we look at the option. You don't have to work out the numerical value with your calculation because the options are in numbers, right? So let's check. I bet the answer is C, right? The answer is C because you can take a look. 100, 100, 100, 4.2, 4.2, 17, 17, 2.5, 2.5, and 50 times 10 to the power negative 3 is 0.05. So the answer is C. Okay? Oh, then I may break down the video into two because as I said, it cannot be longer than 15 minutes. Okay? So enthalpy change of combustion can be used to determine the enthalpy change of formation. Okay? Combustion for formation. Okay? By using the standard, okay, what is the value of the standard? Wow, okay, easy. This is formation. Now, if you remember, we have an equation. If all the combustion are given, then it will be equal to the combustion of reactants minus combustion of product, right? If formation are given, then it will be the other way around. It will be product minus reactant. So basically, right now, your delta H is delta HF. Delta HF, okay, will be equal to the combustion of reactant, this one and this one. 4 combustion of hydrogen plus 5 combustion of, 4 combustion of carbon, 4 combustion of carbon, okay, carbon, plus 5 combustion of hydrogen minus the product, minus the combustion of butane, right? Then you just have to substitute the number, you will get the answer. Combustion of carbon is this one. Combustion of hydrogen is this one. And combustion of butane is this one. So it will be negative 129 kJ per mole. So the answer is B, okay? Basically, you just have to apply this equation, combustion of reactant minus combustion of product. Then you can work out the answer, okay? Oh, and then this one. In a calorimetric experiment, this amount of fuel is burned, only 45% of energy can be absorbed by this water. Okay, now first, we work out the amount of energy absorbed by water. Okay, that would be mc delta T, right? So the m is 200, the c is same as before, 4.2 is given, and the temperature change is this one, 66 minus 18. So it's this one. Okay, now then, this is actually the energy absorbed by water, but the energy released from the field is more because only 45% of the energy can be absorbed by water, right? If you got this number 40320, okay, then how can you find this back? We will divide this number by 45%, right? Common math question. So therefore, the total energy released from 1.6 gram fuel, gram fuel will be equal to this amount divided by 45%, because I can transfer 45%. It's equal to so you will get this number, okay? And the question asks you, what is the amount of energy released per gram of fill. Now you have 1.6 gram, so the answer will be this one, released per gram of fill, because it's from 1.6 gram fill, right? So if you have to work out per gram of fill, you're going to divide by 1.6. So it's this one, okay? The answer is B, okay? Oh, question 11, which equation represent the change corresponding? Wow, very easy. Enthalpy change of atomization is defined as the enthalpy change is always positive, right? Because you need to break down the bond. The energy required when 1 mole of gaseous atom is formed from its element, right? So let's take a look. This is 1. The answer is this one. Now 1 mole of gaseous atom is formed. This is also 1. This is not 1, right? This is not this is not correct because iodine exists as solid at its normal state. So in its elemental form, right? So C is the correct answer because it is its normal state. Iodine is solid, right? When 1 mole of gaseous atom is formed. Oh, let's take a look. Oh, here now, this is easy. Atomization, as I told you, is always positive because you need to break the bond. Formation can be positive or negative. Solution can also be positive or negative. So the answer is B. Okay. And remember, neutralization and combustion. Okay. Combustion is always negative. Atomization is always positive. Okay. Well. And then what data do you need in order to work out this delta H? So basically, you learned an equation, right? Delta H is equal to the formation of product minus formation of reactant. Okay, but remember the formation of all element is 0. You remember, right? So basically, you need this formation, but this one you don't need because it is an element. So the answer is this one, enthalpy change of formation and enthalpy change of formation of this, okay? Then by applying this equation, you can work out the delta H, okay? Okay, that's the end of the multiple choice question. I paused this here because the video is pretty long already. I will get back to you in the part 2 to go to the long question, okay?